Namaste viewers, welcome back to my channel. In this video I am going to discuss short tricks for linear transformation. Okay, the first short trick is, if you consider transformation t of x comma y equal to x plus 1 comma y. Okay, if any transformation is given like this, it is not a linear transformation because here constant term is added an order list of numbers. That's why it is not a linear transformation. The reason is, if any constant, here see, this is the constant, plus 1 is added. Okay, constant add in a tuple. Okay, that is not linear transformation. Okay, this is the first trick. We can prove by using necessary condition also. Okay, then what is necessary condition? If you take transformation is mapping from V to W, okay, the necessary condition is t of 0 equal to 0. Okay, this 0 element is belongs to this set, and this 0 element is belongs to this vector space. Okay, this 0 is belongs to vector space V, this 0 element is belongs to W vector space. Okay, and after checking the necessary condition, we can apply the property or definition of linear transformation. The first property is t of x plus y equal to t of x plus t of y, and the second one is t of c into x, that is equal to c into t of x, where c is belongs to scalar field. Okay, field is set of scalars. Okay, here x and y belongs to vectors V, vector space V. Okay, and see, in place of x and y you take 0 comma 0, we get this as 0 plus 1 comma 0, that is 1 comma 0. This is not equal to 0 comma 0. Okay, this not satisfy the necessary condition. That's why it is not a linear transformation. Okay, we can prove by using the definition also, linear transformation definition. Okay, and second trick is t of x comma y comma z. Okay, if it is given 3 tuple, this is 3 tuple. Okay, 3 tuple nothing but a tuple with 3 elements. Okay, here x, y, z are the 3 elements. Okay, or we call this as vectors also, 3 vectors. Okay, this is equal to x comma y comma z plus 10. It is also not a linear transformation. Okay, for tuple constant is added, that's why it is not a linear transformation. It is also not a linear transformation. The same necessary condition is satisfied. Necessary condition is not satisfied. Okay, that's why it is not a linear transformation. And third trick is t of x comma y comma z is equal to x into y comma y comma z. Okay, it is also not a linear transformation because any two elements in the, say, okay, for in the given transformation, here x and y are multiplied. If you apply the definition of the linear transformation, it is also not linear transformation. We can prove by using scalar multiplication. Okay, scalar multiplication property. Like for example, if I will consider t of, suppose we can check this property, t of c into x, that is equal to c of t of x. We can check by using this property also. Okay, for example, like consider, if I will consider u is equal to x1 y1 z1. Okay, then c is equal to, okay, we can prove generally. Then we get t of cx. Okay, t of c into u, that is equal to t of c into u is nothing but this one, x1 y1 z1, that is equal to t of, if you multiply c inside we get cx1 comma cy1 comma cz1. Okay, that is equal to, now apply the linear transformation. In place of x, cx1, in place of y, cy1, in place of z, cz1. Okay, what we get here, cx1 into cy1 comma cy1 comma cz1, that is equal to c square x1 y1 comma cy1 cz1. Okay, this is c of c into u, sorry, t of c into u. Now we check c into t of x. Okay, otherwise you can take this as u. This is u, this is t of u. Now check c into t of u. That's nothing but c into t of u. T of u nothing but, apply the transformation, we get t of u is equal to x1 y1, okay, y1 z1 we get. That means t of u nothing but x1 y1 y1 z1, that nothing but, that is equal to, if you multiply c inside we get c x1 y1 c y1 c z1. If you compare this both, okay, the first term is not same. Okay, these both are not same. Okay, t of c scalar multiplication is not satisfied. T of cu is not equal to c of t of u. Okay, that's why it is not a linear transformation. Okay, the fourth trick is same, t of x comma y. If suppose transformation is given like this also, x into y comma y into x, it is also multiplied, right? Okay, it is also not a linear transformation. And fifth one is, suppose something is given like this, x comma y comma z comma t. Okay, that is equal to x comma y comma z x t comma z plus 11. Okay, here if you observe that here x z x t are multiplied and the constant term is added to z, it is not a linear transformation, not a linear transformation. Okay, next sixth, if t of x comma y comma z equal to mod of x comma y. Okay, here modulus is there, modulus. Okay, it is also not a linear transformation, not a linear transformation, because scalar multiplication property is not satisfied here. Okay, suppose if I will consider c is equal to, if suppose I will consider c is equal to -1, okay, any scalar. Okay, if I will consider vector as u is equal to, okay, the vector is in the form of like this, x comma y comma z, then I will consider 1 comma 0 comma 0. Okay, right, I will consider like this. Then if I will take now I will apply the t of c into u, that nothing but t of -1 into 1 comma 0 comma 0, that is equal to t of, if I will multiply -1 inside I will get -1 comma 0 comma 0. Now applying the transformation, okay, in place of x replace -1, in place of y 0, that means I will get mod of -1 comma 0, that is mod of -1 is 1 comma 0. Okay, the same, now apply c into t of u, that nothing but c is -1 t of u, this is u. What is t of u? T of u nothing but t of 1 comma 0 comma 0, that nothing but 1 comma 0 we get. That means here we get 1 comma 0. If you multiply minus 1 inside, I will get minus 1 comma 0. If you compare these both are not same. Here 1 comma 0, here minus 1 comma 0. That means scalar multiplication property is not satisfied here. Okay, t of c into u is not equal to c of t of u. Okay, this property is not satisfied. It is not a linear transformation. Okay, next seventh property is t of x comma y comma z. Here mod of x plus y comma z. Okay, here also it is also not linear transformation because the modulus is there. Okay, it is not a linear transformation. Not a linear transformation. And eighth one is t of x comma y comma z comma t, that is equal to x square y z comma t. Okay, here if you observe that the vector, okay, the vector contain a power. Okay, the vector contains a power. It is not a, okay, linear transfer. It may be any power, not only 2, it may be 3, 4, any power. If suppose vector contains a power, okay, it is not a linear transformation. It is not a linear transformation. Okay, next ninth one is t of x comma y is equal to x comma y raised to the power of 11. Okay, it is also not a linear transformation because if you observe that power, okay, y contains a power here. Okay, it is not a linear transformation. Not a linear transformation. Okay, next 10th property is t of x comma y comma z, that is equal to mod of y comma z plus 1 comma x raised to the power of 5. It is not a linear transformation because it contains a modulus and constant term is added to z, and x contains a power also. It is not a linear transformation. Okay, this is the most important problems. Okay, this is the one of the most important problems. Okay, these are the some short tricks you can apply directly in examination. Okay, means in objective questions. Okay, I hope you liked this video. If you guys like this video, please like the video and comment if you have any doubts, and subscribe my channel. Thanks for watching.